All right, it's Friday afternoon for me, and I'm going to try and make about 5 more videos this afternoon, probably about 3 of them just on the normal distribution alone. So this is 12.5 of the chapter we had almost finished on the normal distribution. So just so you know what's going to happen, I still have to give you a test on chapter 12, and I have to give you a 50-point test on chapter 7 and 8. I'll probably give you the test on chapter 12. Maybe I don't know which one. I guess I don't know which one I'm going to get first, so just ignore me. All right, so, but you will get a 100-point test on chapter 12. We covered 12.1 through 12.4. We went on break before we went on break. And now we're going to do 12.5. And then we've covered now 7 and 8 through videos, and those have been sent to you. Then we just have chapter 10 to cover, and you'll have an exam on chapter 10, and then we'll be done. So we're not going to have a final exam, as I mentioned before. All right, so chapter 12 is on, first of all, distributions. Before we get to the normal distributions, generically, it's on distributions. So I'm going to give you a very simple, it's called a rectangular distribution. If I rolled a dice a number of times, sometimes it would come up a 1, sometimes it would come up a 2, sometimes it comes up a 3, sometimes it comes up a 4, sometimes it comes up a 5, and sometimes it comes up a 6. Now, if I rolled that dice 600 times, I would expect that approximately 100 times it would come up a 1, 100 times a 2, 100 times a 3, 100 times a 4, 100 times a 5, and 100 times a 6. So I call that a rectangular distribution. They're not very common, but basically, when everything is equally likely, it's a rectangular distribution. Most things are not equally likely. For instance, if I'm looking at home ownership and the value of homes, as home values go up, the number of homes at that value go down. So if I gave you a graph where this was the value of homes, and then over here I had the number of homes sold, you would find that lower priced homes tended to sell a lot more homes than higher priced homes. So when I get particularly over $1 million, so there might be $1 million, there aren't very many of those homes. But when I go for maybe a $90,000 home or a $100,000 home, would probably be more common today. If I get a $100,000 home or a $200,000 home, there's quite a few of those kind of homes that get sold. But the more the value of the home goes up, the fewer and fewer of homes we get. We call that a tail on the right because there's a very few people on the very right hand side, and we call that skewed to the right. If something is skewed to the left, it looks basically the reverse. So if I was to do your test scores and then the number of students, extremely high test scores, there will be a bulk of students over here, not that many with 100, but there is a cutoff on a test. And then there'd be a few students way over here who just didn't do well. So this would be number of students. And that would be skewed to the left. It's easy to think of examples of things that are skewed to the right. For instance, income. There are very, very few people who have really, really, really high incomes. And not and then the bulk of the people have normal size incomes. When I have something skewed to the right, the mean, the average that gets calculated by adding them up, is greater than the median. If something is skewed to the left, the mean is below the median. And again, if you'll remember, the median is the halfway value for points. I'll probably send you those diagrams in two pictures. Okay, so the next thing, and the bulk of this chapter is on what they call the normal distribution. So I'm going to introduce the normal distribution in this video, and then I will stop this one, and then I'll go to another video where I'll go into more detail on how it's used. A normal distribution is often referred to as the bell-shaped distribution. It looks sort of like a bell. And the mean and the median are both exactly in the middle, and half of the people are above the mean and half of them are below the mean. So the mean and the median are equal. Or I shouldn't say people, does not necessarily people. It could be hours that somebody works on a job, or it could be how long a tire lasts that's been placed on a car. I'm getting a couple of my tires replaced. I got a couple of my tires replaced today. It could be how long a light bulb works before it burns out. These are things that will typically be normally distributed. There are a few that last really, really long and a few that last not as long. By the way, one of the ways those of you who are parents of teenagers can tell how well your teenagers drive is to look at how long their tires last. If their tires do not last very long, that means they are braking fast, taking off fast, and doing what they call burning rubber. So you want to be aware of that. Okay, so there's your normal distribution. Now, when you have a normal distribution, basically you look at the area under curve to find out a little bit about that normal distribution, and it's typically defined by its mean, which we call mu because it's a population, and its standard deviation, which we call sigma because it's a population, and that defines the um, the deviation. So whenever you're dealing something with a standard deviation, you'll typically be told the mean and the, or sorry, normal distribution, you'll typically be told the mean and the standard deviation. And the mean is in the middle. It cuts the distribution in half. So half of the population, however you're defining the population, will be above the mean and half will be below the mean. Everything else is defined basically by that standard deviation. It tells me where is everything else with respect to that mean. So I'm going to give you a simple example that you might be familiar with. The mean IQ in the United States is 100 points, and the standard deviation is approximately 15 points. So if I were to look at the normal curve and I talk about the population of people and their intelligence, IQ is an intelligence quotient, basically a measure of intelligence, the measure of intelligence. And so if I were to look at that, it would say that basically half of the population have IQs above 100. By the way, an IQ of 100 means that your intellectual age and your physical age are the same. So if your IQ is 110, it means you're intellectually higher than you are physically. In other words, you're smarter than average. If your IQ is below 100, it means you're intellectually below where you are. The standard deviation being 15, if I cut the curve, then this would be 85 and this would be 115. One standard deviation below and one standard deviation above. That is a very, very common place for people to fall. And I sent you a handout and it shows you, I sent it to you about a week ago, I guess, that shows that that's 68% of the population. That basically a little bit more than 2/3 of our population fall within one standard deviation below and one standard deviation above the mean. These are typical. Okay, so if you have a child and they test his IQ and it comes back as like a 92 and you go, ooh, that's below average. No, that's well within the range of typical. It's a very, very typical IQ. 68% of the population fall between 85 and 115. If I go another standard deviation above and another standard deviation below, so this is 1 sigma above, and this is 2 sigma above, and this is 1 sigma below, and this is 2 sigma below. Then that takes me from 70 to 130. This is considered normal, and it's about 95% of the population. So 95% of the population have IQs between 70 and 130. Those people are considered normal. Okay? I remember there was a number of years ago, a movie called Forrest Gump came out, and Forrest Gump's IQ tested, I think, around 75. And his mother says, that's normal. And they said, well, he's on the slow side. Yeah, maybe, but he's well within the range of normal. He's not considered mentally disabled. Okay? If I go another standard deviation on either side, that gets me up to 145 and down to 55. That is accounts for about 99.8% of the population. We're virtually all in that category. That is considered where most of our population fall. The people between 130 and 145 are considered genius level. They get to join special clubs, if you will. And these people are considered mentally disabled. We used to use the word retarded. We don't use that word anymore. Although it is still technically a term, it's just been used as a pejorative so much that we don't use it anymore. And then over here, if you're above 145, you would be a mega genius. So people like uh, the character who was on that TV show. Oh, my brain's leaving me now, so I'm not gonna be able to remember. The Big Bang Theory. He was a mega genius, kind of a strange character, but he was a mega genius. Stephen Hawking, who died not too long ago, he was a mega genius. His IQ was well above 145. I'm not sure exactly what it is. You could Google it. If you're below 55, you are severely mentally disabled. I have a friend who has a daughter whose IQ is about 29. She's an adult of about, I think she's about 34 years old now, and she still only talks in very, very simple sentences and singular words like McDonald's, McDonald's, McDonald's. When she wants to go to McDonald's, and then she'll say hamburger, 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 but she doesn't have conversations. She doesn't have the mental capacity to do that. Sweet child. I call her a child. She's 33 years old, but she's a child. Okay? All right, so that's your basic thing. This, by the way, is called the empirical rule. And there'll be a couple questions where they'll talk about, based on the empirical rule, what would be account for 68% of the population. And you would just take your mean and add one standard deviation and then subtract one standard deviation. And that would tell you what that value should be. Okay, I'm going to stop this video at this point.